2 is integral exponents or properties of exponents. So you've seen properties of exponents before. Here's a brief rundown. You have, if you have the power of 1, then you get the same number back, like 5 to the first is 5. Power of 0 is always 1. If you don't remember learning like why that is, some of these other properties are actually going to help make that one make sense. So if we have a negative exponent, we send it to the denominator, or if it's in the denominator, we can send it to the numerator to make it positive. So negative exponents just kind of flip things. Like this 4 to the negative 2 would be 1 over 4 to the positive 2, or 1 over 16. So if we're multiplying like bases, we're going to add those exponents. So we have 3 to the second times 3 to the fourth. We can add 2 and 4 and get 3 to the sixth. If you have a power raised to a power, you multiply. So if you look at this example, 2 will be raised to the third. That gives you 8. X squared raised to the third, 2 times 3 gives us 6. And y to the first raised to the third, it gives us y to the third. If we are dividing, we, sorry, I was thinking about this one. Up here, we're just saying that anything inside parentheses is going to get that exponent on the outside. Now this property, remember when we start talking about polynomials later, doesn't work when there's addition and subtraction going on, but as long as it's just multiplying and dividing in those parentheses, then you do distribute your exponent. This is the same concept, and then this is the one I was trying to talk about a minute ago. If you're dividing like bases, you're going to subtract those exponents, which is where this property makes sense. So if we say I have 7 to the second over 7 to the second, if I write that out, 7 times 7 over 7 times 7, then that divides, and I really just have 1 times 1, and I get 1. So using that subtraction, if we said 2 minus 2, so we just did it using the 2 minus 2, we would have 7 to the 0. So anything to the 0 power is going to be 1. All right, so some examples of what you might see in your Math Excel and on a test. Let me make this where we can all see it. Here we go. All right, so we're going to simplify. We know that we have finished simplifying when there are no parentheses left. Each base only appears once, and we have no 0 or negative exponents. All right, so this one is pretty simple. We're just going to take each piece that's being multiplied here and raise it to the fourth. So if we do negative 2 to the fourth, we're going to get, what is that? 2 times 2 is 4, times 2 is 8, times 2 is 16, and it was negative 4 times, so it ends up being positive. Then we can do x to the third to the fourth, so we'll do 3 times 4 is x to the 12th. And then we have y to the first raised to the fourth, so y to the fourth. So 1 times 4 is 4. All right, here, these parentheses are just kind of separating that I want this thing times this thing, but I'm going to multiply like pieces. So if we do negative 7 times negative 2, we get positive 14. If we do x squared times x to the third, we'll add those and get x to the fifth. And then y to the eighth times y to the negative eighth would be y to the 0, but then remember that's just 1. So 14x to the fifth is what we have. All right, I know if I get to talking too fast, y'all just make sure that you pause, rewind, whatever you need to. All right, here, this is just a big division problem. Remember, a fraction bar just means divide. So again, we're going to divide like pieces. So negative 4 over negative 2, and I'm just going to highlight on this one instead of rewriting things. So negative 4 over negative 2, definitely meant for that to be blue. It'll be all right. All right, so we get negative 2. All right, so then if we do the x's, 3 minus 5 gives us x to the negative 2, because 3 minus 5 is negative 2. And then y to the 7th over y to the 4th will give us y to the 7 minus 4, so y to the third. All right, I'm going to go back and write this in orange just so it's a little easier to see. All right, so -2, that's just a regular old number. We're going to leave it be. X to the -2, though, since it's a negative exponent, has to swing to the bottom. And then y to the third was a positive exponent, so it gets to stay on top. Another way of doing this, instead of showing this step, is you can think that you have 3 of these here, so it's going to knock 3 of those off and leave 2 on the bottom. And then you have 4 of these here, so it'll knock 4 of those off and leave 3 on top. And then just divide those regular numbers. All right, so number 4. All right, so the negative exponent on the outside, you can go ahead and flip and square everything, but with 54 in there, I don't really want to do that. So let's simplify what's inside first. So it'll be a lot like this problem. 54 divided by 6 is 9. We only have that y on top, and these two z's will knock this down to 5. 7 minus 2 is 5. So we'll have this, and then we raise it to the -2. All right, so what that means is we need to do 1 over 9y z to the 5th and make all of that to the +2. So then we just square all of those things on the bottom. So 9 squared is 81. This becomes y squared, and 5 times 2 gives me z to the 10th. All right. So same concept here. I don't want to cube a 30, so we're going to go ahead and simplify on the inside. So -30 divided by 10 is -3. A to the 14 over a to the 17. 14 minus 17 is going to give me a negative, so we're going to move it to the bottom because there's more on the bottom. So we'll have 3 left in the denominator. And then 8 minus -2 means I'm really going to add. So I'm going to get b to the 10th on top. Another way of thinking about that is this negative would have to come up here to make it positive, and then you have them being multiplied, so you add. All right, so now we have all of this to the third power. Sorry, I didn't realize I was such a big eraser. What was this? B to the 10th, and then all of that to the third. All right, so -3 to the third. -3 times -3 is +9, times -3 is -27. It's a power raised to a power, so this becomes b to the 30, and then a to the 9th. And that's all for that one. All right, so number 6. Remember I said earlier, anything to the 0 power is going to be 1. Now that's a loaded statement when you take calculus. Anything to the 0 power is not 1 because 0 to the 0 doesn't fit the bill. But for this stage of the game, anything they give you to the 0 power, you're just going to say 1. All right, these last 4, I think it's just 4. Nope, sorry, there's 6 more. These last 6 I made to look like the weird problems in Math Excel. The things on your test are going to look a lot more like 1 through 6. But 7 through 12 are good examples to help you out with Math Excel. All right, so for order of operations, we have to multiply and then we can do the subtract. So if I put just these two together, that's going to be -3w to the third. Then we have minus, and then let's put these together. So that'll be negative times a negative, so +35w to the third. And then now we're just combining like terms. So -3 minus 35 is -38 of those w to the thirds. All right, so on the next one, kind of the same concept. We got to figure out what this is. So b to the -8. And then we have subtraction. And then we have a negative b to the -2 raised to the 4th. So a negative raised to the 4th, anything that's negative raised to an even power is going to turn positive. So I brought this down, but then this becomes positive because it's to an even power. And then we have multiply -2 and 4, and you get -8. So now it's something minus itself, and anything minus itself is 0. All right, so for this next one, we have a negative over a negative, so that makes a positive. I'm going to write out that we got a positive, not something you really have to show. Actually, I'm just going to call it 1/3. How about that? Because it's like a 1 on top and a 3 on bottom. Can y'all see that? There's a understood 1 there. So we're going to call this positive 1/3. All right, for the p's, you're going to have -1 minus 1 if you subtract. So p to the -2, which would put it in the denominator as a positive p squared. For the q's, you have a -1 minus -3. So that ends up being -1 plus 3, so q to the +2, so that goes on top. Now that 1 that's up there with that q squared is not necessary, but you don't have to go back and erase it. All right. Number 10, if we take this right here and do it, we're going to get, what is that, 2/3. Those are both reduced by 3. So, let me think. Here we go. All right, so we're going to do -2/3. You can do 2 over -3. You can do negative out front. You can put a negative on top. It really doesn't matter where that negative lands. All right, for the C's, that's an eraser, not a highlighter. For the C's, you're going to subtract those exponents. So we'll have, why can I not keep up with my colors? We'll have 9s minus 3s. So that would give us C to the 6s. And then for the D's, you have 4t minus 8t, which gives us -4t. So we'll stick it on the bottom. Now, sometimes in Math Excel, they tell you that variables represent positive integers. Sometimes they tell you nothing about your variables. So if you think you have it right and you type it in and it tells you that you're wrong, just come ask me a question. Email me a question if you're at home working, because sometimes like they don't make you move things to the denominator, because just because 4 is negative and we don't know what t is, we don't know that that -4t actually is a negative exponent. Because if t was negative, then it would be positive. So anyway, if you type something in, you think you're right and it's not telling you that you're right, then just check with me. I'll be happy to help. All right, so here, nothing super crazy going on here. We just got some fractions. So remember, we're going to multiply numerator times numerator. So 1 times 1. Denominator times denominator. So 6 times 7. And then handle everything else the same. You got x to the -2 times x to the +2. So if I write that out, again, not necessary to show this step, but we're going to get this. And then for the y's, you'll get this. So then if I put all of that together, this is just 1, so that's not there. This y to the -5 needs to be in the denominator. So ultimately, my answer here is 1 over 42 y to the 5th. All right, last one. There's not a whole lot happening here that I can simplify. I mean, I could, but I'm going to go ahead and show you how I can handle this when the numbers aren't too bad. Actually, well, there's more than one way to do it. I can simplify the inside and then do the exponent. I'll just do what I told you I was going to do. So if we take this -3, I'm just going to show you what it looks like if you like, for some reason, do it this way. So then it'd be -3 times this. And then this would be 2 to the -3, and then this would have -3 times -3m. All right, so we're going to say definitely these have to switch. So it'll be 2 to the +3 over 3 to the +3. So that would give me 8 over 27. For these, I'm going to distribute this. So this will be -6m plus 3. And down here, it'll just be 9m. So then when I handle what's going on with the A, we're going to take the -6m plus 3 and subtract 9m. So that would give us A to the -15m plus 3. And don't quote me on this, Math Excel will take this because, again, I don't know for sure that that's going to end up being negative because I don't know what m is. If it doesn't take this, then just put the a part on the bottom. Make it 8 over 27, a to the -15m plus 3. Again, I think that this is going to work. If it doesn't, come see me and we'll work it out together. All right. Always, if you have questions, email me and let me know.